Hey, welcome, guys. I want to do a quick review from this unit on the different methods that we use to solve quadratic equations. Notice some of them are a little more efficient than others, and we want to be aware of how to use each method and what are their strengths and weaknesses to get you ready for your quiz coming up. So let's look at the factoring method first. So remember, when you factor, your goal is to create the parts of a polynomial. And when you set them equal to zero, you're going to end up getting the actual solutions to the equation. So for a quadratic, you always get two binomials. Okay. Um, Now, sometimes you can have a GCF out front that has a part that you could set equal to zero also, but usually this is the look of them. So we did a quick review from the Algebra 1 factoring methods. The first method is by GCF. We always look for that first. We will get into this grouping method with four terms later on in a future unit, so we won't see this type yet. However, you're going to see a lot of the general try scenarios pop up where the A is 1. So you just take the factors of 30 that make the middle term. 5 and 6, they both have to be negative to get negative 11 in the middle. And the last terms have to multiply to plus 30. Remember, we use divide and slide method when the A is 1 and there's no GCF. So we taught this one, but remember what you do is you take the 5 and multiply by the C term to get 30. In this example, and notice how you take the factors of the 30 that make 17 in the middle, which would be 15 and 2. And remember to divide the last terms by what you multiplied by in the beginning. So because I multiplied by 5, I divide by 5 at the end. 15 divides 5 even, so that's how you get x plus 3. 5 doesn't divide 2 evenly, so the 5 slides in front of the x. That's your factor point. So I have to know when to use this divide and slide method. The key where kids mess up on this is they forget to reduce fractions before they slide. So like this one, easy, it's divided easily, but sometimes if I had something like x plus 6/9, you replace that with 2/3, and then you would slide 3. So that's a common error. Another helpful factoring method is called the difference of squares. So if I have the difference of two perfect square numbers, you can split it into two binomials where the x squared splits to x and x. You square root it, you get x and x, and then the 81 becomes 9 and 9, and then you have a plus and minus on the signs. So if I gave you an example like x squared minus 25, that would just be x plus 5 times x minus 5. The last factoring method that we mentioned in class was the perfect square trinomials. This was very good with the complete square method. So remember, to be a perfect square trinomial, the first and last terms are perfect squares. And it turns out that if you square root the end pieces and double their products, you'll always get the middle term. So like in this example, there's no GCF, but we notice the first and the last terms are perfect squares. When I square root the first term, you get 11x, and I square root the 4, you get 2. Turns out when you double those, you're going to get 44 in the middle. So that's how I know it's a perfect square trinomial. And it would factor to double set of 11x minus 2's. Okay, so that's a nice method to refer to. So in the example we're doing, we're just going to stick with this single problem. We're going to solve it a bunch of times. So what you can do is do the Gen factoring method. All right, because there's a one out front, so you just take the factors of 8 that make it in the middle, which would be 4 and 2. And what would happen is then you would take each linear factor and set them equal to 0. So when that happens, you would solve for x on both. The first one's -4, and the next one's 2. There's your two answers for the x-intercepts. So if I were to type this into Desmos or my graphing calculator, let's check it real quick. What you would notice is if I typed in x squared plus 2x minus 8 and hit graph, you'll see it hits the x-axis at 2 and -4. Those are your solutions. So you could also solve this by graphing, which is by far a lot easier because it doesn't require any skill. So that actually is method 4. We can make a sketch and show that the x-intercepts would be 2 and -4. Notice the y-intercept is -8 down here, but we just really care about the x-intercepts. Another way to solve this same equation is by completing the squared. And remember, to do this, the number in front of the x squared term has to be 1. So what we do is we bring the 8 to the right side, and then we complete the square on the left side. And make sure you add it to the right side of the equality. In order to complete the square, what we have to do is take the b term, which is 2, you cut it in half, and then square it to get what goes in that box. Well, that's 1 squared, which is 1. So if I add 1 to the left side, I add 1 to the right side. So what happens is the left side is now a perfect square trinomial, which would easily factor to double x plus 1s. Notice the left side is really x plus 1 squared, which equals 9. So then the next step to get rid of the square on that binomial is to square root both sides. So then I get x plus 1 equals plus or minus 3. You don't want to forget your plus or minus on the right side of the equality when you square root both sides. Then I subtract 1 over. Notice I get 3 minus 1, which is 2, and -3 minus 1, which is -4. The same two answers as we got by factoring. Notice for this specific problem, I can't use solve by square rooting because there's a b term in the equation. So this method is not even viable for that type of problem. We'll talk about this one towards the end. We're going to take that same exact equation and solve by using the quadratic formula. So I taught you guys how to remember the song for this formula. The nice thing about the quadratic formula is it works all the time, and you'll always get solutions. It just requires a little bit of plugging in and making sure you're doing your arithmetic right. See, where factoring only works some of the time because some of these are unfactorable. So we have to realize there's limitations to the factoring method. Complete the square works all the time, but it can become a little bit more complicated when the b term is odd. So that's why I only use this method when the b term's even. So let's use the quadratic formula. So I wrote the song. So A is 1, B is 2, and C is -8 as long as the equation's in standard form. So when you set it up, it's very simple. You think of -b first, and I do that in parentheses, plus or minus the square root of b squared, in parentheses, right? Minus 4 times the a, which is 1, times the c, which is -8, all divided by 2 times the a. When you simplify the formula, you do one piece at a time. Under the radical, we follow PEMDAS. So we always do the exponents first. So what would happen is you would get 4 from 2 squared. You would have to multiply these first before you subtract. So 4 times 1 times negative 8 is negative 32. What happens is you end up with a double negative, which is positive. So notice the next step would be negative 2 plus or minus the square root of 36 over 2. So then I would get negative 2 plus or minus 6 over 2. That's how we get our two answers. Negative 2 plus 6 is 4, and 4 divided by 2 is 2. There's one of my answers. Negative 2 minus 6 is negative 8 divided by 2 is negative 4. Keep in mind, sometimes your answers do not turn out as integers. You may have to leave it in its radical form if the radical doesn't reduce or doesn't become an integer. So you can leave it in radical form for its two solutions. So in this case, notice it's the same ends as the other. Okay. Now, something very neat that I want to show you guys that I haven't taught you yet is called the polynomial solver tool. That is on your graphing calculator. So literally what you do is hit the apps button on your calculator and you go down to what's called the PLYSMLT2 app and type the equation into your calculator. So the cool thing about it is you select option 1, which says polyroot finder. And this screen pops up with some setting options. Okay, so the order is the degree of the polynomial. So it's a second degree. So I need to make sure that 2 is highlighted. I want to make sure my answers are in A plus BI format. It doesn't matter if it's decimal or fraction. Fraction's a little more precise if it'll let you do that. Leave it on normal. The float setting is just the rounding of the zeros. So I'm just going to leave it at 1 and leave it in degree format. Then I hit the next button, which is the graph button, and type in the coefficients from the polynomial right into an order. So this a2 is in front of the x squared, which is just 1. a1 is 2, and then a0 is your constant, is negative 8. So once you type straight into the app, you just hit solve, and it gives you your two answers, negative 4 and 2. By far the easiest way to solve. The problem with this is that if I don't have a graphing calculator or your professor will not let you use it, you're not going to use this method. But it's nice to use this as a background tool if you're able to use a calculator. So that's a game changer. All right. A few other things that I want to discuss is solving by square rooting. This was a separate lesson that we discussed. So when you do this method, remember the b term has to equal 0. So all I do is take the equation that has 1x squared term in it and isolate it. So in this example, I would subtract 25 over. I get 3x squared equals 73 minus 25. So notice I get 48. 3x squared would equal 48. Divide by 3 to get x squared equals 16. Notice the next step would be to square root both sides to get x equals plus or minus 4. So I could even square root in this type of problem because there's no bx term. There's no single bx value. So I can just isolate. Another classical example, solving by square rooting, would be an example with a binomial squared. A common algebra mistake is students will try to distribute the 2 through that binomial, and you cannot do that because the square means there's 2 sets of those. You don't want to distribute the 2 out front either. What you would do is get rid of the 2 out front by dividing both sides by 2. So now I have x minus 4 squared equals 3. Then, to get rid of the square, then I would square root both sides. So notice I get x minus 4 by itself equals plus or minus root 3. Don't forget the plus or minus. Last step, add 4 over. So notice I get x equals 4 plus or minus root 3. Those are the exact x-intercepts in radical form. Now, one other case I wanted to show you guys was if I wanted to solve by completing the square when the a is not 1, the strategy here is to get rid of the 3 out front by dividing the whole equation by 3. So every term is divided by 3. The temptation you're going to see here is this might look like it's a perfect square trinomial already. Turns out it's not, because if I were to square root the n pieces into x and 2, and then double those, I don't end up with 2x in the middle. See, it should be 4x. So I know it's not a perfect square trie as is. So what I do is bring the 4 to the right side. Then I can complete the square on the left to make it a perfect square trinomial. Remember to take half the b term and square it. Notice that it's positive 1. So I add that to the other side to balance the equation. So remember, this now becomes a nice pretty trinomial, which factors into double x minus 1s, which is really x minus 1 squared. The right side is negative 3. So to get rid of the square, you square root both sides of the equality to get x minus 1 equals plus or minus I root 3. Remember to simplify radicals when they pop up in your equations. So our last step is to add 1 over. So your solutions would be 1 plus or minus I root 3. Two imaginary solutions this time. What this actually means is if this was typed into decimals, it would not touch the x-axis. You would get two imaginary answers. Okay, the last scenario we have to discuss is how to convert the three forms of a quadratic. So these go back to a lot of core Algebra 1 skills that you're going to see on your quiz coming up. So the first thing I have to recognize is that you can't go directly from vertex to intercept. You have to go through standard. So remember, standard form is in that ax squared plus bx plus c form. So to get your parabola in intercept form, this one right there, what you have to do is factor. And remember, when we factor, we always pull a GCF out first. So let's show that step. A 2 comes out of each term. So notice I got x squared minus 4x plus 3, which then would become a gen trie inside that parenthesis, which would factor to two binomials. The only way to get 4 in the middle is to take 3 and 1 and make them both negative. So this becomes the intercept form of that same parabola. Notice it has the a x minus b x minus q form. To go from intercept back to standard, you have to multiply or FOIL it back out to what you started with. So we'll make a note and show the steps over here. So I want you guys to see that. So now I will take the double binomials and FOIL those first. FOIL. The first terms would be x times x squared. Outside terms would be minus 1x. Inside terms is minus 3x. Last terms is plus 3. So notice I will get x squared minus 4x plus 3. The 2 out front would then get distributed to become 2x squared minus 8x plus 6. Notice it goes right back to where we started from. So if I want to go from standard to vertex, notice vertex form is in this look right here, a parentheses x minus h squared plus 5. So the beauty behind this is to do that, you would have to complete the square. So let's show the steps on that on the side. So basically, to complete the square, I am going to bring the c term to the left side. So remember, we don't divide it out. We just bring that c term over first. So we get y minus 6 equals 2x squared minus 8x. Now, to complete the square on the right side, I need to factor out a 2 out of these first two terms, because you can't do it unless there's a 1 in front of the x squared. So notice a 2 goes out front. So now I have x squared minus 4x left in the parentheses. Then I can complete the square, because now there's the 1 in front of the x squared in the parentheses. So technically you're not factoring out the entire GCF of the right side, but it's just the GCF of the numbers. So to get what goes in this box, you take half of negative 4 and you square it. Well, negative 2 squared is positive 4. The C term is always positive. Where you have to be careful is because I added 4 here, and that 2 is multiplied by it, you actually add 8 to the other side to balance the equation. So notice on the right side, I end up with 2 double x minus 2's in its factored form, which is really 2 times x minus 2 squared. The left side becomes y plus 2 because of 8 minus 6. The last step is to subtract the 2 to the right side. So notice your vertex form would look like this. Notice the vertex would be the coordinate positive to the negative. You take the opposite side of the 8 and the k value, and it gives you a lot of features off that rather. So the last thing I want you guys to see is how to go back from vertex to standard. So literally all you do is multiply this back out. So what we're going to do is just say multiply. Now let's make sure we know how to do that. So I'm going to bring this over here and we're going to multiply. I'm going to write the x minus 2 twice. So the first thing you'd want to do is FOIL the two binomials before you distribute the 2. So what would happen is when you use the monkey face on this FOIL, so the first terms would be x squared, outsides minus 2x, insides minus 2x, last terms plus 4, you're going to get x squared minus 4x plus 4. The 2 could then be distributed, and then the minus 2 outside stays out there. So notice I get 2x squared minus 8x plus 8, then minus 2. Notice that ends up becoming what you started with, because 8 minus 2 is 6. So we would end up with our same exact standard form. So I'm hoping that you guys are seeing how to go back and forth from forms, as those are important algebra skills. And we can't go directly from intercept to vertex or vertex to intercept. It has to go through standard. So hopefully this will help you guys have a good foundations to make sure we're getting ready for our assessment coming up. All right, we'll see you guys later.